Good morning, good afternoon, everybody. We are thrilled to be with Chris Miller, and I'm fortunate to have props here this morning. Chris is a professor at the Fletcher School at Tufts University, an acclaimed author, an expert on all things economics, geopolitics, and technology. His latest book, Chip War, The Fight for the World's Most Critical Technology. For those who haven't read it in anticipation of today, I am desperately pleading / asking everybody to go out and do that. This is a really thoughtful but fun book to read on much of what I would have said is called the 20th century, but maybe some of the 21st century as well, through the lens of the development of the semiconductor industry. You'd be shocked, because I was shocked, on how many aspects of the world that we know today, not just the physical technological world, but the social world, the political world, the geopolitical world, have been kind of born out of sand, I guess, is the description. So we're thrilled to have Chris with us. And, sort of going to start by just having a little conversation here and then open it up to questions for those in the room and those online as well. So welcome.
Thank you.
Maybe to start, because I'm always interested, how did you get here to find this as a topic of such interest? I know you have a lot of experience in history earlier in your life and career around Russia and Russian history, but how'd you kind of get to semis as such a broad topic?
So as you said, my background is in Russian history and politics, and I first got into semis by trying to write a book on Russian history. And the question that puzzled me was why, if you looked in 1957 or 1960, you would have thought the US and the Soviet Union were essentially at parity in terms of the technologies that mattered. Nuclear weapons, long-range missile systems, rockets. Actually, the Soviets were the first in space, first man in space, first dog in space, first monkey in space. They had all the firsts. If you zoomed forward 30 years to 1985 or 1987, it was obvious that the US was far, far ahead in the technologies that mattered. And in that time, the early technologies like space systems had barely changed at all. The space shuttle was, I guess, a marginal improvement on the Apollo system, but not a whole lot. Whereas computers had dramatically changed every other aspect of human life. And they were at the time putting computing power equivalent to the Apollo spacecraft's guidance computer in everyone's house, and now they're putting it in everyone's pocket. And so that question of, well, why did the US do that and the Soviets didn't? Despite that, they had Nobel Prize winning physicists and brilliant engineers and lots of money. Seemed like a puzzle. And it was a particular puzzle when I learned that the US invented the first computer chip in the late 50s, and the Soviets did so 2 years later. So there wasn't any real difference in starting point, but the US had come to dominate the entire chip industry. And so that got me interested. And then I learned that China spends as much money each year importing chips as it spends importing oil, which I hadn't been taught in school, but seemed pretty important for understanding the world economy. And final fact, I learned that 90% of the most advanced chips are manufactured by one company on one island, which also happened to be the centerpiece of US-China competition, and that's Taiwan. And so it seemed to me there was a story worth telling there.
Oh, good. Well, you helped me along because trying to figure out how to organize this talk, I had mentioned to you earlier, there was just such these large themes that clearly, cut through the last 75 years of our life, and you just mentioned a bunch of them, whether it's the Cold War or Taiwan or China more broadly. But why don't we start this way? I thought maybe it'd be helpful to describe to folks in a very abridged layman's way the architecture of a chip, because I think it will help inform the conversation when we just sort of understand what are we talking about in terms of how a chip is actually made.
Yeah, so a chip is a piece of silicon in most cases, often the size of your fingernail, like the chip inside of your phone or chips in your PC. And inside of a chip or on top of a chip are carved millions or now billions of tiny circuits, which are turned on and off by a transistor, which is a switch. And so when a circuit is on, it produces a 1. When it's off, it produces a 0. And all of the ones and zeros undergirding all digital computing, all your Instagram likes, all your emails, all AI are these circuits flipping on and off. And today, chips are so powerful in terms of the computing they deliver because they have so many of these transistors. And you can fit 10 billion transistors or 20 billion transistors on the primary chip in your smartphone because they're tiny. And so the smallest transistors, like the ones in your smartphone, are measured in nanometers, billions of a meter, roughly half the size of a coronavirus. And so you've got 10
Like really
billion.
pause on that for a second because we were talking earlier, like when you're thinking about small now and Moore's law and things of that sort, like small means atoms.
Atoms. Yeah, so I was just mentioning there's a machine, one of the machines involved in chip making can lay down thin films of materials that are 4 atoms thick. And so you've got to do it with perfect uniformity because if you lay down 5 atoms, you're 25% off. And that's the level of precision you need.
So it is really the oil of the 21st century. So in terms of big themes that I found, kind of interesting from a historical perspective is sort of is just as you said, the post-World War II world and almost sort of the birth of Silicon Valley. Can you talk about some of the, kind of most remarkable characters? Because I know there were a lot of characters involved with, many of these original, companies. But, what did the world look like in Silicon Valley back then? How important, I'm leading with, was the military
Mhm.
as, kind of a driver of innovation and these types of projects?
I think the first thing that I hadn't really realized, although it's obvious once I say it, is that Silicon Valley wasn't called Silicon Valley until
Yeah.
1971. And it was just that it used to be called the town south of San Francisco. And of course now when you say Silicon Valley today, you think of Google or Facebook. If you watch the TV series, that's basically what you see. But in the 70s, that's not what you saw. You saw actual factories making silicon chips. And it was entrepreneurs like Bob Noyce, who was the founder of first Fairchild Semiconductor, then Intel in the late 60s, who really built up Silicon Valley on this manufacturing capability. And the manufacturing was, by the standards of today, super basic. So Bob Noyce would drive up and down Highway 101 in the Bay Area, stopping at different camera shops to buy lenses, to jury rig machines together, buying toxic chemicals by the bucket load. Most people are surprised here that Silicon Valley has the largest number of Superfund sites of any place in the United States, largely due to the chip industry. They've cleaned up now, thankfully. And the vision was simple, was that if you can drive down the cost of making chips, you can put them in everything. And that's something that people like Noyce realized as early as the mid 60s. And so Gordon Moore, his co-founder, after whom Moore's law is named, predicted 1965 personal home computing devices, portable computers, and networked communications, which more or less describes our reality today. And it sounds pretty anodyne when you put it in those terms, but actually you can see they were envisioning the world we live in and producing the chips that made it possible.
Before iPhones, before AI, what are the chips that we're talking about back then? And
Yeah,
and maybe just, all chips are, I mean, all potato chips are not all computer chips,
yeah,
but
yeah,
but not all chips are the
yep,
same. Are we talking mostly about memory and what was jammed back then?
yep.
Yeah.
Yeah, so the first chips were for military and space systems. And so they had, your iPhone has 10 billion transistors. They had 10 or 20 or 30 transistors on them. And so there were both processor chips that would undertake a type of logic. So a guidance computer, for example, would guide your rocket where it's supposed to go, and memory chips that would remember a given program. And those two basic categories still exist today. So your phone, your computer still have processor and memory chips. They've just gotten literally a million or 10 million times better,
Hmm.
depending on when you start the clock. And today, the industry is still divided into those two basic categories of things that process and things that remember.
Got it. I think that has a lot to do with how kind of the winners and the losers played
Yep.
out over the last number of decades. But so on to the next big theme to sort of discuss through this is just the concept of globalization. We talk about it a lot in our business, and it means different things in different industries. But talk a little bit about kind of globalization in the context of the semi industry and the supply chains and kind of who does what,
Yep.
because I think that will be a good, launching pad for
Yeah.
us.
Yeah. So the early globalization was driven by what you'd, I think, associate with globalization, cheaper labor costs in East Asia. And so as early as the first half of the 1960s, chip companies in Silicon Valley were opening facilities in Hong Kong and Singapore and the Philippines solely for labor cost arbitrage. And for the first decade or two, that was the story. But that drove the construction of really capable industries in places like Taiwan, in Korea, in Singapore, and in Japan. And so today, globalization of the chip industry is not at all about labor cost arbitrage. Labor is sort of irrelevant because everything's so automated. Instead, each region has focused on a specific part of the value chain. So the chemicals are largely manufactured in Japan, a lot of materials and super specialized materials because you can't have the wrong atom in your material. That's all largely done by Japanese companies. The tools that manufacture chips, like the tools that lay down these thin films materials, are largely manufactured in Silicon Valley or in the Netherlands. or in Japan. And then the manufacturing itself, bringing everything together, the materials, the designs, that all happens in Taiwan right now. And so you've got this specialization along the value chain where no one can do it on their own. Not a single country can produce its own advanced chips. Everyone relies on this single value chain that stretches from Europe through Silicon Valley and then ends up in the final manufacturing steps in East Asia.
It almost feels like this industry, more than others I can think of, is even more
Yeah.
specialized by company or by
Mhm.
geography than most other industries. How did that become
Yeah. I think that's been the only way to deliver the technological advances that have been required.
scale because of scale?
Scale, yeah.
Right,
Scale because both the capital expenditures are vast. So every new cutting edge chip making facility is the most expensive factory in human history.
right.
So every 2 years we build the most expensive factory and it's more expensive than the prior one. But also the R&D costs. You
Yeah.
need to defray that over a very large market because the R&D is super specialized. And so at the chemical level, at the tool level, at designing the software tools that lay out where each of your 10 billion transistors go on the chip, that pattern matters. And so there's only a couple of companies in that space because they also need to be super specialized and defray a ton of R&D over the entire market.
Yeah. Yeah. And maybe sort of now take this reality of the global supply chain and start talking about some historical and current dynamics in geopolitics.
Yeah.
So, let's talk a little bit about the Cold War and Russia in particular. They put Sputnik in the air. They had more guns and ammo than we did. Um, what about Russia and their approach to innovation um, kind of stymied them in terms of, never mind leapfrogging, but even catching up?
Yeah. Yeah, I think there were three challenges they faced. So number one was that if you look at the 1960s, almost all chips sold went to government applications, space or defense. Today, by dollar value, 2% go to government, and the rest goes to smartphones and AI and PCs. And so that only happens if you've got a civilian market, which in turn only happens if you've got a venture capital ecosystem plus a incentive structure to encourage people to go to the civilian market. And so if you look at Bob Noyce or Gordon Moore, the entrepreneurs I mentioned, their first customer was NASA, but they didn't make their money off of NASA. They made their money off the consumer market. That was challenge number one in the Soviet Union. Challenge number two was that they were afraid to globalize. It didn't fit their ideology. And so whereas Bob Noyce and Gordon Moore opened their first factory in Hong Kong for labor cost arbitrage, didn't work so well in a socialist system.
Right.
And challenge number three was that the Soviets were always trying to copy.
Yeah.
And this was, I think, the part that was surprising to me because I thought if you were pretty good at copying, you could stay caught up. The Soviets were very good at copying. They had students at Stanford as early as the 1950s who were studying with industry leaders and Nobel Prize winners. They were regularly smuggling in tools through Austria and through South Africa. They copied so much that although the rest of the country was on the metric system, the Soviet chip industry measured in inches. That's how much they copied. And they were very good at copying. On a regular basis, the US would acquire some piece of Soviet military equipment, pop it open, and find Texas Instruments chips inside, or replicas of Texas Instruments chips inside. But in an industry that races forward at an exponential growth rate, if you copy, you're guaranteed to be exponentially behind. And so if you copy 2 years behind the cutting edge, you're half as good. If you got to be 4 years behind, you're in a much worse position. And so that basic dynamic condemned them to being behind, and they never made any progress in closing the gap.
Ballpark, when did they figure out that this was sort of not a winning strategy in the context of the Cold War?
Yeah. I think by the early 80s, it had become clear that not just their chip industry, but therefore their computing industry, therefore their entire economy and military were behind. There was a moment in the early 80s when the head of the Soviet general staff told an American journalist from the New York Times, Cold War's over, you guys have won. Every American uses a computer in elementary school. We will never replicate that.
So a lot of learned lessons for the world on communism, socialism, kind of global supply chains. Maybe sort of transition now to China.
Yeah.
For a long time, I was sort of shocked I guess not shocked, but to see that they really kind of disavowed the importance of developing an industry. Why was that the conventional wisdom at that time?
I think for a long time, until 10 years ago, China realized that it couldn't compete, that the cost was just too high, that it made more sense to focus on other industries where you had a much better chance of winning market share. And so it was only around 2014 that China really began targeting semiconductors as a potential growth industry. And there were two reasons. One, I think because they wanted to move the value chain. And if you look at all the iPhones that are assembled in China, all the components are imported, and it's semiconductors that are the high value components. They're imported from Taiwan and Korea and Japan. And so if you want to actually extract value from electronics assembly, you've got to do more than just assemble. You've got to make the chips inside. So that was part one. Part two was that if you're sitting in China worried about worst case scenarios, and your number one component in your import bill is semiconductors imported from Taiwan, Korea, Japan, the US, i.e. all countries that are military allies of your primary rival, that's not a very secure situation to be in. And so as part of Made in China 2025 and a bunch of the other industrial policy plans, the Chinese government has been prioritizing this as a key industry, both for the upside of technological gain and value creation and to mitigate downside risks of losing access.
I mean, the first question is they're pretty good studiers of history. How did it not kind of work itself into the collective thinking until 2014, having watched the Cold War, having watched how the story ended for Russia in 1989 or 1990? Yeah. Where's that kind of 25-year gap in terms of chips are important, we need them? We were trying to figure out, can you think of one part of your life, like one physical place, one moment in your day where you aren't interfacing with a chip? Like I actually can't think of one, which is sad slightly. But how did they not kind of understand that like the future of everything, frankly, was going to be directly correlated to their ability to have chips? And if you have a geopolitical kind of dynamic where all the allies are on the other side and they happen to be the manufacturers of this global supply chain, it's probably not a great space to be.
I think if you were to have done an analysis in 2010 of the international supply chain, you would have determined no one can produce advanced chips on their own. The US cannot produce advanced chips on its own, full stop. Couldn't do then, can't do it now. And so if you're China, which is at that point the number 3 economy in the world, but still a developing country by any metric, why would you think you could do it if the US, which invented chips, can't do it on its own? And so it's actually, I think, in a lot of ways, a rational strategy to focus your marginal investment dollar not in an industry where you're unlikely to catch up, despite spending tens of billions of dollars, focus somewhere else. I think what changed is the politics changed over the course of the 2010s. And it became much more important in China's eyes to think about the worst case scenario. And once you started thinking about that, your access to semiconductors seemed like your most critical vulnerability. At the same time, the industry itself has gotten more and more and more concentrated as every year passes. And so 20 years ago, there were a bunch of firms that could produce at the cutting edge, and no one had really outsized market share. Today, there are at best 3 firms that can produce at the cutting edge. TSMC of Taiwan has 90% market share for advanced chips broadly defined, and 99% of market share in AI accelerators. They probably have 100%, but they're afraid to admit it because antitrust regulators might come knocking.
99 is fine, guys.
You're supposed to say north of 80.
No, I mean, I get it, and kind of focus on the things that you can do and the things that you're good at. And on the other thing, what I guess I don't get is kind of any kind of debate around a global supply chain or any debate around necessity for global supply chains and capitalism and specialization in one light, and in the other light, just ignoring it, right? Like I don't see how you can sort of do both, but apparently you could for a period of time. What's China's approach now to creating a domestic chip industry? Have they kind of foregone the concept of a global supply chain, or are they going about it differently than Taiwan or Korea or the US or Japan or anybody else?
Well, one point first on ignoring it. If it was ignored in Beijing, it was also ignored in Washington, where we've allowed ourselves to have our biggest companies be critically dependent on basically 2 factories in Taiwan to produce the most important chips, Apple, NVIDIA. You go down the stock market by market capitalization and ask, how would these companies survive without it? So it was only in Beijing. I think in some ways, China's trying to replicate right now what Taiwan did in the 70s and 80s and Korea did in the 80s and 90s. Insofar as it's providing companies with subsidized capital. It is trying to attract talent. These are all tried and tested strategies. The difference is that China's trying to do it on its own.
Focused on memory?
Focused on both memory and logic. Across the board. Because China, I think, rightly believes that its access is threatened across the board. And so it's got to try to do it all at once. And that's the key difference with both Taiwan and Korea. Both Taiwan and Korea is specialized in one segment of the supply chain. So every factory in both Taiwan and Korea relies on imported tools from the US, Japan, and the Netherlands, relies on imported chemicals from Japan, relies on imported software from the United States. And TSMC in Taiwan produces chips largely for US customers. 70% are US customers, and Apple is 25-ish% of revenue every single year at TSMC. So TSMC is a Taiwanese company, but it wouldn't function without the United States. Whereas in China, the goal is to become completely reliant of the US and much less reliant on the Taiwanese and the South Koreans. And I understand that goal from a political perspective, but of course, it's much harder to achieve.
I mean, I want to one sidetrack, but we're so lucky to be having this conversation with both a chip/China/Taiwan expert, but also a Russian expert on the heels of Russia-Ukraine. But before I get there, tell us what fabless manufacturing means and how that sort of plays into the industry and some of these geopolitical dynamics.
Yeah, so one of the key industry shifts was when the design process became separated from the manufacturing process. So in the early days, you both design and manufacture your chips in-house, but as both sides got more complex, as designing meant laying out billions of transistors, and as manufacturing meant manufacturing at nanometer scale, it became clear it was better to specialize. And so today, most of the big chip companies that you know of, like NVIDIA, like Apple, which designs many of its own processors, like AMD, like Broadcom, they've manufactured nothing ever. They've all relied largely on TSMC to do all their manufacturing, which has been a great decision insofar as economics are concerned. And it will be a great decision as long as nothing happens to Taiwan. Minor asterisks, because it's been extraordinarily efficient. So TSMC's got this huge scale. They produce on time every single year. Apple doesn't have to worry that its primary supplier might miss a deadline because it never has. And it's worked out great. The only problem is that it's based in Taiwan, on Switzerland.
Perfect segue. So on the heels of Russia-Ukraine, obviously, Taiwan and its role in Chinese-American relations has become even more kind of front and center. How does sort of the role that TSMC plays in this, essential, cannot fail global industry, how do you think that plays into the political dynamics and how kind of tension around Taiwan unfolds?
Yeah. I think the way I came to understand TSMC was by looking at their founder, Morris Chang, who I think, we all know about Bill Gates and Steve Jobs. I think Morris Chang deserves to be put right next to them in the pantheon of sort of technology titans, if you will. And his life story illustrates, I think, the challenges that Taiwan finds itself in. So he was born in Ningbo in China right before World War II. Spent the wartime in Hong Kong and then in Chongqing, fleeing Japanese armies. Then moved back to Shanghai after the war ended, except the Civil War was going on, and so had to flee Shanghai in 48, moved to Hong Kong, got admitted to Harvard in 50 or 51, was the only Chinese student in his class at Harvard, for an extraordinary fact.
Wow.
And then moved to MIT. His uncle told him to study something useful rather than Shakespeare. That's what he was studying. And got a job at Texas Instruments, where for 3 decades he held a security clearance to develop specialized electronics for the US military. And then he had this idea of the foundry model, splitting design from manufacturing. The Taiwanese government, where he had no family connections, he just done business as a TI executive, gave him a blank check to set up a foundry in Taiwan, which became TSMC.
And why Taiwan sort of have that? Talk about offset and sort of Taiwan's view of politics and global politics at that moment.
Yeah. So Taiwan, until the US switched recognition from Beijing to Taipei, Taiwan was China and was defended by a formal US security guarantee. Then the US lost the Vietnam War, started pulling out from Asia, switched recognition to Beijing, and Taiwan was very, very, very nervous. And so they continued to bet on military means to defend themselves, but they also said, if we want the US to continue helping to defend us, we need something besides the Cold War history. So let's attract supply chains. And that's exactly what they did with extraordinary success.
Talk about some foresight.
Yeah,
I mean,
incredible.
To pick the industry that is that essential. And so as you think through the various ways that kind of the Taiwan situation could play out, how do you sort of calculate the risk around military intervention versus economic intervention versus naval intervention? I mean, how does that play out for an industry like this? Never mind an earthquake or something.
Yeah. The good news about an earthquake is that for general manufacturing, the facilities need to be so vibration proof. So they're actually hanging from air. They have big pylons, and then the facilities themselves, the entire factories are hanging from air to make sure that nothing causes vibrations. So they're supposed to be capable of surviving a 9.0 earthquake
Wow.
on the Richter scale, of which there have only been 4 in the world in the last 100 years, none of which have been in Taiwan, which is no guarantee that there couldn't be one. But if you talk about military scenarios, the simplest, most basic escalation in military terms or in blockade terms would cause immense disruption because TSMC needs to import many of its raw materials. The chemicals come from Japan, the components, tools come from Japan and the US and the Netherlands. So the moment anything bad happens, the supply chain freezes up and it is very difficult to restart. And so I think that makes it a very binary situation. Either it works or it doesn't work. And if it doesn't work, everyone suffers. We suffer, the Taiwanese obviously suffer, and China today suffers immensely because the #1 consumer of Taiwan's chips is, of course, China, at least assembly plants in China. The final demand for that is often re-export to the rest of the world. But if you're an employee at a Foxconn factory assembling iPhones, you really want your TSMC-made chips to keep coming into China. So you could argue there's a form of mutually assured economic destruction right now, that if anyone messes with the supply chains, everyone loses. And I think insofar as you believe that all the parties are rational calculators trying to maximize GDP, I think you should feel relatively comfortable about the next couple of years. I'm not sure I believe that all of the people involved are necessarily rationally calculating to maximize GDP. And I think you can find some examples like in Russia, Ukraine, where that hasn't been the calculus.
So that could lead to a potentially cataclysmic outcome. Not to put you on the spot to solve China-US relations, like right here
Easy
this
problem,
morning,
yeah.
but what would be your best guesstimate as to how this, kind of tension unfolds? Like, what's the stalemate?
Yeah. I think muddle through is the
Yeah.
optimistic story. And we've been muddling through since 1949
Right.
with relative success, I would say. There was a brief couple of years in the late 50s where the US was threatening nuclear weapons use against mainland China over the Taiwan Straits. We forget that today.
Yeah, feels
So
bad.
there were some rough points then, but I think muddling through is a plausible scenario. The risk is that one of the sides believes that they have a bit of scope to push further and push in a way that the other side doesn't deem tolerable. So things that we know would be problems. If Taiwan declared independence,
Right.
that'd be a problem. And so hopefully they won't do that. And I think they've signaled that they probably won't. And the US has publicly said they shouldn't do that. So I think I feel relatively good around that risk, but if it happened, it'd be very bad. I think the real challenge is on the Chinese side. 50 years ago, if there was a war, everyone knows who would win. Today, if there's a war, nobody knows who would win. I think that creates a whole lot of uncertainty. And I think there are people in Washington who will quietly admit that the following scenario would put them in a very tough position. Imagine if China said, only to the LNG tankers that go into Taiwan. Taiwan imports most of its energy, and they're in the process of shutting down their final nuclear plants. Imagine if the LNG tankers had to first clear customs in Fujian province on the Chinese coast before transiting to Taiwan. Well, if they were to do that, then that would be, I think, a pretty clear signal that Taiwan was incapable of defending its autonomy. And if the US allowed that the US was unwilling to defend Taiwan. So that would be a big change to status quo. But if you were the US president, would you send in the Navy to escort LNG tankers into Taiwan? It's not implausible, but it's an extraordinary risk given that Taiwan is very far from the United States. The entire Chinese Navy is right there. And your generals will tell you that your air bases in Guam and Japan are on the top of the Chinese strike list, and your missile defense is probably won't hold.
It's terrifying. I mean, talk about quick escalation. That is some seriously quick escalation. How is the state sort of responding to this Chinese focus right now? And maybe talk about sort of the CHIPS Act and tariffs and subsidies, and not just sort of what exists, but your view on the efficacy of it and sort of what works and what doesn't.
Yeah, so I think since China focused on the chip industry and devoted a lot of money in the probably low tens of billions of dollars a year in government support from 2014 to present, the US and Japan and Europe and to a lesser extent Korea and Taiwan have responded with their own subsidy programs on the grounds that tariffs probably don't work as a trade remedy tool if you're unhappy with industrial policy, and so you need to do your own industrial policy. That's been the rationale. And so in the US, we're devoting $39 billion to directly incentivize firms to build manufacturing facilities.
I know it's going to sound ridiculous. Is that a lot of money?
Yeah, so TSMC CapEx last year was around $35 billion. So it sounds like a lot of money.
Yeah, it is a lot of money.
It is a lot of money. And that's $39 billion over, 5-ish years. There's also a tax credit that essentially doubles that. But it's not as much money as one might think. And the cost gap between producing in Taiwan versus producing in the US is ballpark 30%. So a $20 billion factory in Taiwan costs a whole lot more in the US. It costs more not because the tools that are inside are any different, they're the same. It costs more because construction is a lot more expensive. And then the ecosystem of materials providers and tool repairers and chemicals, that all exists in a much more dense and therefore cheap fashion in Taiwan than it does in the US. And so we've succeeded in dramatically increasing the rate of investment. The last couple of years, there's been something like a 10x increase in the rate of investment in chip making facilities relative to the prior decade. So if your goal was to increase investment, that's succeeded. TSMC now has a plant in Arizona, which is, as of now, producing chips as efficiently in terms of manufacturing as it does in Taiwan. In terms of cost, it's still 30% more expensive, but the yield of chips is as good as Taiwan. So that's a positive. But of course, we're paying a lot for this, and it's not clear it's going to be financially viable absent ongoing government subsidies. And $39 billion every couple of years starts to be pretty expensive.
So in addition to sort of subsidies and tax and things of that sort, talk about a little bit sort of the bans on, some of these critical choke points in supply chains to China, and whether or not that's working, and I guess how the Chinese can get around it, and your thoughts on that.
Yeah, so I mentioned that inside of a TSMC facility, the tools inside come from basically 5 companies in the US, Japan, and the Netherlands. 1 Dutch, 1 Japanese, and 3 American. And that's true of basically every chip making facility in the US. They all have the same tool set, more or less, inside. That's true of SMIC, which is the leading Chinese chip company. They also have the same tools inside, or at least they used to until a couple of years ago when the US stopped allowing the most advanced tools to be sold. And so now China is struggling to advance its chip making capabilities. TSMC will point out that SMIC was 5 years behind TSMC 10 years ago. It was 5 years behind TSMC 5 years ago, and it's 5 years behind today. And that's correct, because SMIC makes progress, but TSMC makes progress, and so the gap remains basically the same. And I think this debate has been supercharged by artificial intelligence. Because the key trend in AI over the past couple of years has been, if you want a better AI system, you build a bigger AI system, which means you buy a whole lot of NVIDIA chips, which are all produced on the most advanced nodes at TSMC. And so the US both wants to keep its advantages rather, it wants to keep Taiwan's advantages in chip making, both for its own sake, but also because those are being primarily used today to drive advances in AI. And so I think China is in a position where it can produce small volumes of 1 or 2 generations behind the cutting edge, but there are still regular stories of people trying to smuggle in NVIDIA GPUs in suitcases into China, which I think is about as clear of evidence as you need that China can't produce what it wants at home.
To copy it?
No, to install in data centers.
Use it.
Yeah.
Hard to get enough volume.
Yeah, so if Elon has 100,000 plus or minus installed in Memphis, that's a lot of plane flights.
Yeah, that's a lot of plane flights. Obviously we will see, but that feels like a very unsustainable dynamic. Does that just mean that sort of, unless kind of, trade relations normalize, China's sort of structurally not going to catch up?
I think if you assume that the scaling laws of AI persist at any exponential rate, but that bigger keeps meaning better, and that's something that Elon and Sam Altman and any NVIDIA investor, they all believe that. So we all sort of have more or less bought into that thesis. If you believe that, and then you make any reasonable set of projections around chip making capacity, TSMC is 5 years ahead of SMIC in 5 years' time.
So a few more, and I'm going to obviously save enough time for everybody to get in here. But AI and kind of the focus on AI, has that, and whether it's NVIDIA or more advanced chips generally, has that changed any of these kind of dynamics from a supply chain geopolitical perspective in any real way, or is it sort of what we've been talking about for the last little bit?
I think it's largely what we've been talking about. And unless the next generation of AI chips doesn't require the next generation of manufacturing, and historically it always has, it's hard to see that changing. I can say with confidence there will not be new entrants into the market to produce $20 billion chip fabs. And if TSMC has 99% market share today, I bet with pretty high confidence they're north of 90% in 3 years' time, and with pretty high confidence they're north of at least 80% in 5 years' time.
It definitely feels that way. Maybe circling back to where we started, which is so much of this industry was, kind of jump started by the industrial military complex. Talk a little bit right now about sort of the future of war.
Mm.
Sadly, the world is engulfed in
Yep.
many of them right now.
Yep.
How do you sort of feel, this looks, whether it's, kind of precision guided stuff,
Yep.
autonomous vehicles, cyber, you name it. Where do you sort of see this playing out in the warfare?
I think AI and military applications sounds a bit science fiction, but it's already being deployed. I guess the sort of most visual example would be autonomous systems. Now, the reality is autonomous systems aren't that autonomous yet. That'll take another decade to play out. Where we really see AI right now is in intelligence. So intelligence is today essentially a big data problem, which means that if you can use computer vision to look at your satellite photos and identify what's a truck versus what's a tank, huge advantages in terms of speed of ability to analyze and therefore act. And so for whether it's tracking terrorists, where their cell phones are located, whether it's hacking into their networks, all of that is being accelerated by AI. And that's not a futuristic thing. It's been in place since 2017 type of set of capabilities, obviously rolled out in more and more applications. Missile defense is another interesting one. We talk about autonomous weapon systems and think of killer drones. Well, missile defense systems have been autonomous to some degree for decades now. They're getting better and better, as we've seen in a really visceral way the past couple of months, looking at Israel's capabilities. And so I think when we think about the military applications of AI, we should actually think more about command and control, think more about intelligence, and then recognize that differentiated capabilities are largely about intelligence, speed of action, command and control, and killer drones, like you've read about in sci-fi novels, might come eventually, but that's not what we should be focused on right now.
Meaning the hardware is kind of going to be somewhat commoditized, and it's really kind of
Probably.
that intelligence that will be the differentiator.
I think that's probably right. Yeah. Yeah.
That's really interesting. I'm going to turn it over to, but my most curious question, I mean, I know enough to know that you were highly kind of, you know, well-read and thoughtful on these topics before you even started the book. What was your biggest surprise that you learned in researching this book? And maybe kind of, I know you mentioned Morris Chang in particular, but some of the individuals and the lessons around entrepreneurialism in particular, because
Yeah.
that's what I found so interesting. What should we all sort of take away from innovation and an entrepreneur, mindset from your learnings here?
Yeah. I think I learned the most about value chains and about technological innovation. I guess for technological innovation, I'd sort of had a mental model of smart engineer meets business plan, and that's the story of success. And I really came to admire in ways that I hadn't expected the supply chain managers, the people who are marketing technology, because a lot of the execution and the vision come not from the engineers. It comes from the ability to turn that into a product you can sell to 1 million people. And so I used to think supply chain management was mind-bogglingly boring. And perhaps part of it is, but I have extraordinary respect now for people who can fine-tune a supply chain. And I think the chip industry provides many examples of that. I think the second thing is understanding value chains ends up being so important. Some of the most profitable companies in the chip industry you've never heard of, and you'd struggle to figure out they existed if you didn't do months of research, because they're like a company in Japan that only sells to 4 chip makers, yet they've had essentially a monopoly with extraordinary profit margins for half a century. And understanding how value creation emerges out of an industry like that, understanding competitive moats that have been durable over decades. I think that's another thing that I hadn't really expected to get so excited about, but I learned a lot about in the process of writing.
It's fascinating. It really is fascinating. So with that, maybe we'll turn it over to questions in the room.
Hi, thank you, Chris and David, for your time. So the question I have partially has been answered by the topics that you wanted to discuss, but so we are 2 years into the U.S. restrictions and the sale of advanced AI processors to China. Through companies like NVIDIA, the country has started building its own high-end AI chips. And China has been a significant buyer of NVIDIA's low-end AI chips. And you mentioned that they've been trying to smuggle AI chips as well. So it's clear that they're behind, but they're trying to catch up. But as you mentioned, it's kind of like clear that it's really hard to do that. So in terms of the next steps, what do you think is going to happen from the Chinese side? And what role would Taiwan play in this? Thank you.
Well, it's an interesting question to ask now, because last week there was I think a really revealing news story about a Huawei. So Huawei is the lead designer of AI chips in China right now. A Huawei, essentially a shell company, going to TSMC and trying to get AI chips produced at TSMC. Which on the one hand, you would say is a pretty big gap in your export controls if you can't figure that out in advance. So that's a fair point. On the other hand, it's a pretty extraordinary mission that you don't have the manufacturing capacity domestically if you're trying to sneak into Taiwan to get AI chips produced for you. I think that fact, coupled with the fact that there's a special category of NVIDIA AI accelerator called an H20, which has been designed down so it's legal to sell to China. And NVIDIA is going to sell 500,000 to 1 million of those to the Chinese market this year. You'd only buy a second-rate chip if you couldn't buy the first-rate chip. And I think that shows that the smuggling channels they exist, but they're not large enough. The domestic manufacturing isn't there at the scale you need. And that's why you would buy the deliberately downgraded processor that you're allowed to get access to. In terms of next steps, I think we're going to see more efforts to try to find workarounds in the manufacturing process to scale up. But the challenge is that TSMC is going to continue its cadence of producing better and better processes. And so you're not catching up to a stagnant status quo. You're trying to catch up to something that's moving forward quite rapidly. And that's why you've really got to assume a major breakthrough in manufacturing or a major paradigm shift to tell yourself a story whereby China's going to catch up in the next couple of years.
Good question.
Any other questions in the room? Yeah.
Can you comment on ASML's role and how it's actually kind of fragile as the only one, right? Like doing what it's doing, right? And we talk so much about TSMC, but I feel like reading your book, I'm really worried about ASML's position, right, in the world. And there's no duplication, there's no redundancy, right? So
So I think there's actually a number of places in the supply chain at the chemicals level, the materials level, but also the tools where there's a single company that is the dominant player. And in the photolithography segment, there'll be a quiz after this, who can pronounce photolithography. ASML is the number one player, really the only player that got 100% market share and the most advanced tools. And just to kind of describe what they do, so to pattern 10 billion or 20 billion transistors on the chip in your smartphone, you need to use waves of light to do your manufacturing for you. And so the light interacts with chemicals in a way that will make them either harden or disappear at the right location to get the transistors. And so you need a specialized wave of light because visible light has a wavelength that is far too large to do the manufacturing you need. Visible light has a wavelength of several hundred nanometers. Your transistors are measured in the single nanometers. So we use wavelengths of light that are 13.5 nanometers. Which is important because it's very, very hard to produce light with that wavelength. So what you do is you take a ball of tin, 30 millionths of a meter wide, you drop it in a vacuum, and then you pulverize it twice by the most powerful laser ever deployed in a commercial device. That tin explodes into a plasma. The plasma measures 40 times hotter than the surface of the sun. It emits light at just the right wavelength. It's pretty close to X-ray, which is a problem because X-rays go through most materials, but they've found a way to make mirrors that reflect 13.5 nanometer wavelength light. The mirrors have to be extraordinarily flat, so flat that the flattest mirrors humans have ever made. And they use a dozen of these mirrors to reflect the light so that it bounces exactly right at the right angle, hits your chip, and carves 10 billion transistors into it. So this is pretty complex.
Where was it Jay Lathrop?
So Jay Lathrop
was where it started.
So tangent. There's a story about, so how did it start? So they were trying to make smaller transistors. First you did it by hand, then it got too small to make by hand. And there was a guy in a military lab who was looking at a microscope, or looking through a microscope to make his chip look larger so he could understand how to manufacture it better. And he and his lab partner realized if you were to flip the microscope upside down, you could take a pattern that was large and make it smaller. And so that was the origins of this super complex optics.
Photography.
And so that's the history of
I found that sort of
it's
incidental finding, or not an incidental finding, but it's the basis of what's now, just sort of wild science.
Well, it's a great innovation. Turn it upside down.
Exactly. It's unbelievable.
And I love it.
Unbelievable.
But
who else? Here we go.
I'm wondering if you could comment on or juxtapose the chip competition to the electric vehicle industry and how, 10, 15 years ago, you would have never thought China could make, a quality electric vehicle. And then now they're sort of taking over to the point that all countries are threatened.
Yeah.
So how are they different? How is this potentially different? And how is it the same?
Yeah. So I think I would say two observations. I think one is that if you were to take someone from 1960 and time travel them forward to 2020, they would be very surprised by how little cars had changed. Anyone alive in 1960 would have no difficulty operating a 2020 car. They might be impressed by the air conditioning. They'd be impressed by the GPS on your phone, right? But otherwise, the function of the car, they've gotten more fuel efficient. They have airbags. You would not be remotely surprised to see a car. If you take someone who'd seen a computer in 1960 and brought them to 2020, of course, they would have barely comprehended what was going on. So I think that gives you a sense of the rate of innovation or lack thereof in those two industries. So that's one. It was easier to catch up on autos because autos had been in my view, underperforming industry when it came to improving the actual technology. Second is that if you look at the process innovations that I think you see at BYD, what you find is that they've done a very good job of taking what Chinese engineers learned in terms of assembling electronics and applied that to autos, which has been, I think, an extraordinary improvement in cost, an improvement in terms of the cycle time, but it's not something that is unreplicable elsewhere. And we've seen Tesla do, I think, more or less the same. That's why they're competing pretty evenly in the markets where they're both present. And I think we're going to see more companies that essentially learn to emulate that. In China, there's many companies that I think are producing roughly comparable cars to BYD. They're not going to be profitable, but they're nevertheless going to remain in the market. So I think that's a big difference in the chip industry because there's such concentration in the chip industry where there's, I think, diffusion very rapidly in the auto industry, which means that you're going to have much more profitable companies in the chip industry because their market positions are durable. And you're going to have durable market positions in part because the technology is going to continue to improve rapidly. Whereas in autos, I sort of expect that if we jump forward to 2034, maybe Elon will have delivered self-driving by then, but I'd sort of take the under on that. I don't think things will look all that different.
Based on the solar roofing world, I'm going to agree with you.
A virtual submission from a colleague at SGI. What key leadership traits do you think Morris Chang embodied, and how did this differ from other leaders in the industry?
So I think two things stand out. So Morris Chang, he started his career at Texas Instruments on the assembly line. So he was a manager of an assembly line. And so this kind of core manufacturing operations was really key to not just his philosophy, but his identity. And he was known for being someone who was able to tweak the assembly line with sort of a intuitive knowledge and wring out efficiency improvements, improve the manufacturing process. And he remained relentlessly focused on that all the way up to really the present day, even though he's in theory retired. In reality, if you want to email him, you email his TSMC email address. Really? So he's not retired. And he's still on a regular basis, I think, intervening to try to improve the manufacturing process. So that focus on manufacturing is number one. I think number two was understanding how the value in the business was going to change. Today, it seems obvious that you should split design from manufacturing because all of the most valuable chip companies have landed on one side of the divide or the other. At the time, it seemed insane because there were, of course, no customers that existed to buy manufacturing services from his foundry. And so when he was at Texas Instruments, he pitched this to the board. He said, let's build a foundry operation. We'll do the manufacturing. Our customers will do the design. And the Texas Instruments board said, there are no customers, which is true. And he said, sort of a version of, if I build it, they will come. And I think not coincidentally, just a couple of years after TSMC was founded, NVIDIA was founded, Qualcomm took off, and many of the key customers that are...
Why did Intel see it so differently?
So Intel, I think, is a story of a company that was too successful for too long, rested on its laurels, but also became fixated on defending its existing businesses, which were immensely profitable and until really 3 years ago. And that seemed very rational. until they were out innovated. The irony is that the phrase disruptive innovation was actually devised partly by looking at Intel. Because Intel managed to disrupt its prior business model in the 1980s.
Yeah.
And
from memory to processors.
From memory to processors, yeah. And the leadership team in the 2000s
Is there any
failed.
kind of feasible pathway for them to regain their leadership position in the world?
I think it's possible to imagine that pathway, but I think it's hard to find people to bet on that being the most likely outcome.
Got it.
Anything else in the room?
Hand you a mic.
Thank you, Chris, for the great book. I'm also curious about the process of you doing the research and putting every piece of information together. Like while I'm reading through the book, I feel like there are a lot of more like a personal stories or conversations going on in parallel in text instruments while at the Fairchild. How did you find all those details or interview or interact with people to put together this history?
It took a lot of interviews to to do, but I think I quickly realized that you couldn't actually understand technological change without people. I think we too often think about technology as being about technology, when in reality it's about taking new innovations and bringing them to market. And that's a process that fundamentally involves people. And so I wanted to understand who those people were, what the choices they thought they had were, what the other option was that they didn't take, and how that would have played out. And so I essentially just started interviewing people and then asking them who are the next 3 people I should talk to, and quickly found myself talking to people all over the world that I hadn't expected to speak with. I think the other thing that surprised me was I sort of thought at the outset I could find the person who could explain it. There was someone who understood how all the pieces fit together. And I realized that if you talk to someone at ASML, they understood their suppliers and their customers, and they only had a really dim understanding of what was happening 3 steps up or 3 steps down. And they were very good at what they did, and they didn't have to understand 3 steps up or 3 steps down. And so there were lots of questions that I found myself asking that no one really knew the answer to, because it was no one's job to really think about how the entire chain fit together. And so I found that to be a fun part of research, trying to piece together how the entire supply chain functioned.
Another virtual submission. The government played a key role in subsidizing the chip industry in many countries, including the US. Are there lessons from the chip industry about when it's worthwhile for governments to subsidize strategic industries versus when the cost is too high to bear?
So I think during the early history of the US industry, it was the military that was subsidizing. And it was subsidizing not really for the sake of subsidizing. It was subsidizing because the military always overpays for things. And that was the subsidy. And so companies knew if you could produce 10 or 100, you could sell it to the military for much more than it cost. That's how contracts essentially worked. And you could use that to learn about the manufacturing, drive down your costs, and then get it to a price point where you could sell 10,000 to corporate customers. And so that was a form of subsidy, I guess, but it wasn't really an effort at subsidization. I think what we've seen more recently are deliberate efforts at subsidization of bringing down the cost of capital for established firms, which is what's happening in the US, in China, in Europe, and elsewhere. And this isn't a place you'd like to be. I don't think this is an optimal situation. And it's particularly ironic because in the US, we're primarily subsidizing highly profitable firms. We're subsidizing TSMC, one of the 10 most valuable companies in the world, extraordinarily profitable to build manufacturing facilities, which you'd only do if you had this sense of extraordinary risk due to the concentration. And I think the reality is that it's the US, but it's also Japan and Europe and China, which for different reasons are looking at the same supply chain and sensing risk that's worth, in their view, paying billions or tens of billions of dollars for. But in an ideal world, you'd find a way to cut a deal and not have to pay that money.
Worse than that, no matter how much money you spend here in the States building foundries, it's not going to solve the ASML issue.
Correct. I think, are you less worried about ASML's production than you are about TSMC's? Probably, just given the geography.
Fine. Yep.
Although I was recently reminded ASML's facility in the Netherlands is only 70 feet above sea level, because all of the Netherlands is only 70 feet above sea level. So as the polar ice caps melt,
How many
beware.
machines do they make a year?
In the low hundreds.
In the low
and
hundreds.
the most advanced ones is in the dozens.
Wow.
Another one from the room.
Any questions here?
So in your book, you also talk about talent. So 20%, you mentioned 20% of the AI talent is from the US, but the US employs 59% of the leading AI talent. And given the upcoming election, how will immigration policy, right, visas, right, these policies affect US ability to protect that talent coming to the US?
Yep. I think a key question, I think it goes all the way back to the history. If you look at the founders of Silicon Valley companies, you see first-generation immigrants everywhere. Andy Grove, the famous CEO of Intel, was actually Andras Grof when he was born, immigrated from Hungary during the early days of the Cold War. I could give you 1,000 examples. So yeah, critically important. I think the interesting irony is that although if you listen to US political debate, you will hear 1,000 complaints about immigration and 1,000 things said that would deter immigrants. If you look empirically at where immigrants are moving to, you still find it's mostly the US. In AI, there's pretty good research done because you can look at the most widely cited AI papers and then track where these people were going to school, where they work, where they were born. And the trend is still, insofar as this is an accurate representation of reality, the trend is still major migration into the US from Europe, from India, from China. Could that change in the future? Certainly could. I think the question you have to ask next to what is US immigration policy is what are the alternatives? And I think one of the benefits that the US had is that although it's erred in many policy decisions recently and in history, the alternatives have made bigger errors. And I think if you look at the world right now, you'll in the AI space or advanced technology space, you'll find Europe is basically irrelevant. And so Europe will continue to be a major exporter of talent to the US. I think you'll find Japan to be a smaller scale, but still an exporter of talent to the US. India will certainly be an exporter of talent to the US. I think China is the one where the combination of US rhetoric, actual US policy, and then Chinese policy could begin to change that, although it's still the case that insofar as we've got real-time data, there's still major talent flows into the US from China, probably smaller than they were 5 years ago. But yeah, I think it's a great metric to track because I think it probably does map pretty closely on to economic success in 10 years' time.
We were talking about that just in the context of the CHIPS Act and Micron building all these facilities in New York.
Yep.
Power consumption, labor, has that been calculated in? And I'm not sure that's totally played itself out.
Well, I think the other aspect of the workforce discussion that is often misunderstood is we talk about AI talent. So who are the AI researchers writing the papers that OpenAI is deploying? But then in the chip industry, if you talk to the people who are building facilities and ask them what's your primary talent shortage, they will say welders.
Yeah.
And welders who have previously worked in chip making facilities because there's special welding techniques that you use in these and others.
Makes sense.
And so the kind of the spectrum of talent that you need is actually quite broad.
Yep.
And super specialized at every individual node. And it sort of makes sense that there's more specialty welders who know how to do chip making facilities in Taiwan and the US because they produce a lot more chip making facilities.
It's funny. We say, for our business on a global basis, whether you're in New York City or Johannesburg or, you name it, the two topics that are the most prevalent topics everywhere you go is one, affordable housing, and two is availability of labor from the most high tech industry to contracting.
Yep.
So it makes sense. I think we're running out of time. Maybe we have
one question.
One last one.
All right. This is from a colleague at BMI. Given the geopolitical tensions around semiconductors, do you think nations will successfully decouple their supply chains, or will global interdependencies continue to drive collaboration despite political divides?
Well, I think it's probably a spectrum between full decoupling and full integration that we're likely to see. I think if you look at what I'll call the West, US, Europe, Taiwan, Korea, Japan, you find no evidence of decoupling over the last couple of years. And actually you find the opposite. TSMC has made the largest foreign investment in US history in Arizona. The second largest foreign investment in US history is Samsung's facility in Texas. And Intel is building a facility in Ireland. And I could give you 1,000 examples of cross-border FDI between Western quote unquote countries. I think the decoupling is probably too broad of a phrase, but the bifurcation you're seeing is China and non-China. And even there, it's still the case that China is spending more money each year importing chips than oil, which is not what you'd expect to see if it was a story of simple decoupling. But are you seeing companies thinking really hard about where do they locate R&D assets? Where do they locate manufacturing assets? Do they have increasingly separate supply chains for their China and non-China operations? That's certainly true, and I think that is likely to persist.
Terrific. Well, thank you, Chris, for being with us.
Thank you.
Thank you for this book. Please, everybody who hasn't read it, but I have a sense that most of you have, get it. And appreciate you being with us today.
Thanks so much.